Hello students, Mr. Spears here with a quick little video tutorial about the calculation rule of adding and subtracting and what to do with it when you're adding or subtracting numbers written in scientific notation. The two examples I'm going to work in this video are actually numbers 15 and 16 from the Calculation Rules in Science worksheet. If you haven't done that worksheet or you just simply want to check your answers, use my work here to guide you. Alright, remember to write a number in scientific notation. What you got to do is you got to move its natural decimal place until you create a new number that's between 1 and 10. Now when you move that decimal place, whether you move it to the left or to the right, you're going to change what happens to the exponent written with the times 10. If I move the decimal place to the left, I cause that exponent to get larger. And if I move the decimal place to the right, I cause that exponent to be reduced. So we're going to use those two tips to help solve this problem. Alright, so in order to add these together and obey the calculation rule for adding and subtracting, what I want to do is I want to get this exponent of 1.8 times 10 to the third, I want it to match this larger exponent on 2.12 times 10 to the 7th, and then I can add my two coefficients together and I can obey the calculation rule. So let me show you what I'm talking about. I need to get this 3 to match that 7. Now how am I going to get this exponent bigger? Well, remember, if I move the decimal place to the left, I make this number larger, and every time I move it, I make it larger by 1. So if I want that 3 to match the 7, I need to move that decimal place to the left 4 times. And so I'm going to go ahead and do that. Move this decimal place 1, 2, 3, 4. Now each of those waves that I create needs to be replaced with a 0. Alright, I'm going to rewrite this number 0.00018, and it's not going to be times 10 to the third anymore, it's now going to be times 10 to the 7th. Okay? And so you'll notice that now my exponents on my 10 match each other. That's the first thing that I need to do. Alright, the next thing I'm going to do is I'm going to take these coefficients of these two numbers and I'm going to add them together just like they were regular numbers. And so 2.12 plus 0.00018. When I add that together, I get a number of 2.12018. Remember that when I'm adding or subtracting, my answer needs to have the same number of places after the decimal as the value of my calculation that had the fewest. So if you look here, between 2.12 and 0.00018, 2.12 has the fewest places after the decimal. And so my answer needs to have that same amount as well. So I look here, here's the second place after the decimal. Will that 0 round that 2? The answer is no. And so what I'm going to do is I'm going to then chop off the rest, and so my rounded answer becomes 2.12. Now don't forget that there is a times 10 that has to be tacked on there. And so I'm going to go ahead and write with this number 2.12, I'm going to write times 10 to the 7th. This answer right here is the correct answer for this problem. Now the reason why our answer is the same as one of our numbers is because this 2.12 times 10 to the 7th is so large and so much bigger than our 1.8 times 10 to the third that the certainty of this number runs out way before I get to this 1.8 times 10 to the third. And so I'm only as strong as my weakest number, so I've got 2.12 times 10 to the 7th. Alright, one more example. What I want to do here is I want to move my decimal so that this power of 3 matches the larger power of 4. Now to make an exponent larger, recall that I need to move the decimal place to the left. And since all I want to do is make the exponent go up 1, I'm going to move this decimal just one place. And so this number becomes 0.432 times 10 to the fourth centimeters. All right, next I'm going to write that the other number right underneath that so that the decimal places match up, and that is times 10 to the fourth as well. Again, I want to point out that our exponents match and our decimals are lined up. Okay, let's take our coefficients and find the difference, making sure that we obey the rule for subtraction. So when you do the difference here between these two numbers, you get as your answer negative 1.168 times 10 to the fourth, and then don't forget your unit, and that would be centimeters. All right, now recall, when you're adding and subtracting, your answer is rounded to the same number of places after the decimal as the value in your calculation that has the fewest. 1.6 has the fewest places after the decimal, and that is one place after decimal, so our answer needs to be rounded to one place after the decimal. So there's one place after the decimal. I look at the next place over to see if it will round, see if this 6 will round to 1. It does. So my answer becomes negative 1.2. I drop all the remaining digits, and so my answer becomes negative 1.2 times 10 to the fourth centimeters. Thank you for watching. My contact information will be at the end of this video if you have any questions. Have a great day.